Okay, so we're going to do question 8.12. So this is basically the case of perfect substitute reference, where the utility function is just a linear function of the two roots. Okay, so we got a utility of b and c is equal to 2b plus 3c. Okay, so this is basically the utility function for a perfect substitute case. So part A of the question asking you to sketch the indifferent curves for utility levels of 20, utility level of 30, and utility level of 40. Okay, so we got PB equal to 15, equal to 10, PC equal to 15, and we got indifferent curves of 20 that we want to draw the indifferent curves for. Okay, so in order to draw the indifferent curve for the utility level of 20, we will just have to equate the utility function to 20. Okay. Alright, so I got u b c equal to 2b plus 3c, and I want to equate that to 20. Okay, so any bundles b and c that satisfying this equation is going to be lying on the indifferent curve with a utility level of 20. Okay, so therefore this is the equation for the indifferent curve with the utility level of 20. Okay, so this is the equation for indifferent curve with a utility level of 20. Okay, so I'm just going to draw that on a diagram. Okay, so I'm just having a normal diagram where I put B on the vertical, B on the horizontal and C on the vertical. Okay, and I have 0 over here. So as you can see, 2B plus 3C equal to 20. That is just basically a linear equation. So basically just a straight line where we draw C on a vertical. So if we rearrange this equation over here, so I got 2b plus 3c equal to 20. So if I rearrange these to make c as a subject, because I put c on a vertical, so I got 3c equal to 20 minus 2b, and so therefore c is going to be equal to 20 on 3 minus 2 on 3b. Okay, so this is basically a straight line with a vertical intercept of 20 on 3 and the slope of negative 2 on 3. Okay, so what I do is I'm going to find a horizontal vertical intercept, and then I'll connect those 2 points together. Okay, so as you can see, if I make C equal to 0 to find a horizontal intercept, okay, then so horizontal intercept is just where the vertical axis, the vertical value equal to 0. Okay, so if I put C equal to 0, then I got B, so 20 on 3 minus 2 on 3b equal to 0. And if you're solving this equation, you find that b equal to 10. Okay, so if I put 10 over here on the horizontal axis, so I'll just say I got 5 over here, so I got 1, 2, 3, 4, 5. Okay, 6, 7, 8, 9, 10. Okay, so that is my horizontal intercept, and my vertical intercept. If I make b equal to 0, then C is going to be equal to 20 on 3, and that is just my vertical intercept. We know that. Okay, so 20 on 3, I would just say this is okay, so I'll say I got 1, 2, okay, so I got over here is 4 and 3 then, so I got 4, 8, 12, 16 and 20. Okay, so 20 on 3 is somewhere here. Alright, so I got vertical, I got horizontal intercept. If I connect these 2 points together, I'm going to get a straight line. Okay, and this is the indifferent curve corresponding to a utility level of 20. So I say this is indifferent curve, utility equal to 20. Alright, so we're going to do exactly the same thing to find indifferent curve for utility level of 30 and utility level of 40. Okay, so utility level B and C equal to 2B plus 3C, and I want to equate that to 30. And then, so I just want to draw this equation on a diagram, and that is just going to be the indifferent curve. Okay, so any bundle B and C that is satisfying this equation is going to be lying on the indifferent curve with a utility level of 30. Okay, so over here, if you rearrange this, you get 3C equal to 30 minus 2B, and so therefore C equal to 10 minus 2 on 3B. Okay, so horizontal intercept in this case is where I make C equal to 0, and so B is going to be equal to 15. Okay, and vertical intercept is where I make B equal to 0, so C is going to be equal to 10. Okay, alright, so this is 10. I think I got it too big somehow. Let's make it a little bit smaller. Okay, so outside this is 10, this is 20. Alright, so the first one is 20 on 3 and 10. Maybe I'll do it smaller as well. So I got here, this is 5 on 3, 10 on 3, so 15 on 3 is 5, and this is 20 on 3, which is here. Okay, so my first line is going to be from 20 on 3 and 10, which is the line over here. Okay, so I just reduce my scale because otherwise it's going to get too big. Okay, so the second line is where horizontal intercept is where C equal to 0, B equal to 15. So I would say this is 10. So this is 12, 14, so 15 will be in the middle over here. Okay, and vertical intercept is where B equal to 0, C equal to 10. 10 would just be 30 on 3, so this is 25 on 3, and this would be 30 on 3, which is 10, which is here. Okay, right, so if I again connect these 2 points together by a straight line, then I'll get an indifferent curve that is corresponding to a utility level of 30. Okay, so this is my indifferent curve 1, this is my indifferent curve 2. Okay, and this is my indifferent curve 1. And I'm going to do exactly the same thing for indifferent curve 3, where the utility level I want is to be 40. Okay, so I got 3C equal to 30 minus 2B. So therefore C equal to 40. Okay, so 40 on 3 minus 2 on 3B. Alright. So therefore the horizontal intercept is where I make C equal to 0, and so therefore B is going to be equal to 20, and vertical intercept is where I make B equal to 0, and so therefore C is going to be equal to 40 on 3. Okay, so I just have to plot these 2 points on the diagram. C equal to 0, B equal to 20, which is here. Okay, and b equal to 0, c equal to 40 on 3, so this is 30 on 3, so 35 on 3, so this is 40 on 3, which is here. Okay, so again, if I connect these 2 points together, I'll get an indifferent curve corresponding to UT level of 40. Okay, so this is my indifferent curve 3. Alright, so as you can see, the indifferent curves for perfect substitute case is just basically straight lines. Alright, now indicate on the diagram the most preferred affordable consumption bundles, given that the income equal 150. Okay, so we are given the prices of the goods and the income, so therefore we should know our budget constraint. Okay, so budget constraint in this case just B times B plus PC times C, and that has to be equal to income. So in this case, the price of B equal to 10, the price of C equal to 15, and the income is 150. Okay. So what I want to do is I want to draw this budget constraint on a diagram, and then I will find a bundle on this budget constraint that is corresponding to a highest indifferent curve as possible, and that is going to be the most preferred affordable consumption bundle for the consumer. Okay, so as you can see, the budget constraint over here is just a straight line again. Okay, so if I want to find again, to draw it on a diagram, I just have to find a horizontal and vertical intercept. So horizontal intercept, where I make C equal to 0, then I find that B equal to 15. Okay, it's from this equation over here. And vertical intercept is where I make B equal to 0, and so therefore I find that C equal to 10. So I got 2 points. Again, I just have to plot these 2 points together on a diagram. So C equal to 0, B equal to 15. C equal to 0, B equal to 15, which is here. Okay, so I will use a red color to indicate that. Okay, which is here. And the second point is where B equal to 0, C equal to 10. 10 is here. B equal to 0, C equal to 10, which is here. Okay. Alright, so therefore, okay, so if I got a straight line, I connect these 2 points together, you can see that it is lying on top of the IC2. Okay, so this is my budget constraint, so it's lying on top of the IC2. Now, as you can see from this function, from this equation over here, if you rearrange these, you get 15C equal to 150 minus 10B, and so therefore C equal to 10 minus 10 on 15B, which is, if you simplify that, will just be 2 on 3B. So as you can see, the budget constraint is having exactly the same slope, okay, as all of our indifferent curve, and exactly the same intercept as indifferent curve 2 over here. So as you can see, they are exactly the same equation. Alright, so therefore they are lying on top of each other because they are exactly the same. So what is going to be the most preferred affordable consumption bundles for one? So as you can see, anything on the budget constraint is going to be affordable. Okay, and the consumer would like to consume on a budget constraint because that's the maximum amount the consumer can consume. Okay, so what point on a budget constraint that is going to be maximizing utility? As you can see, any point on a budget constraint is going to give the consumer exactly the same utility of 30, because they are lying exactly on top of the indifferent curve 2, and we know that every bundle that is lying on the indifferent curve 2 is going to have a utility level of 30. Okay, so therefore any point on the budget constraint is going to be giving consumer exactly the same utility, and so therefore all of them are going to be the optimal bundles. Okay, because they are all the same, they are just having the same utility of 30, and so therefore everything on the budget constraint is optimal. Alright, because they are just identical. Okay, so I'll say because budget constraint is the same as the indifferent curve too, so therefore any bundle on a budget constraint will have the same utility of 30. Okay, and so therefore all of them are optimal. Okay, so anything or any bundle on a budget constraint is okay. The consumer can consume any of them, and they are just going to give the consumer exactly the same utility. Okay, so part B asking you to show the change in demand that occurs if the price of C is increasing to 16. Okay, so now it doesn't change our indifferent curves, okay, because our utility function remains the same. So there's nothing changed to the indifferent curve. The only thing different is the budget constraint now, because we got a different price for PC. Okay, so our budget constraint is now going to become 10B plus 16C, and that is equal to 150. Okay, so I would like to draw this now on a diagram. Alright, so what is my horizontal intercept? So if I make B equal to, C equal to 0, then B is equal to 15, which is like before. So horizontal intercept remain the same. Now vertical intercept is where B equal to 0. Then my C now is 150 divided by 16. Okay, and so that would be 9 point something. Okay, so that would be 9 point something. Alright, so in terms of a diagram, now horizontal intercept remain the same at 15, so that is fine. So I'm going to use the blue color. Okay, so horizontal intercept remain here. However, the vertical intercept is smaller than 10, so it would be somewhere here. I will just say, for example. Okay, so that is basically 150 divided by 16. Alright, so if I connect these 2 points together, I'm going to get my new budget constraint under the increase in the price. Okay, so this is my BC2. Okay, so what is going to be the change in the preferred affordable bundle, in the most preferred affordable bundles for the consumer now? Okay, so what is the change in the demand for the goods? Okay, so now we would like to find the point on the budget constraint that is corresponding to the highest indifferent curve as possible. Okay, because we want to maximize the utility, so we want the consumption bundle to be on the highest indifferent curve as possible. Okay, so as you can see now, what point on the blue line should we pick? Should we pick this point, this point, this point, or any other points on the blue line? Okay, now corresponding to each of these points going to be a level of utility, and as you can see, this point over here on the horizontal is going to be corresponding to the highest indifferent curve. Now the indifferent curve for I would say the indifferent curve for this point on top over here is going to be like this. So I should just use a black line. Okay, so corresponding to the top bundle over here, this is going to be the indifferent curve corresponding to it. Okay, so it's just parallel to all the black lines and going through that bundle. Okay, so that black line over there is going to be the indifferent curve going through this point over here on the vertical axis, and as you can see, any other points on the blue line is going to be corresponding to a lower utility level than the bundle on the horizontal over here. Okay, so therefore this bundle over here is going to be the optimal bundle because it is lying on the highest indifferent curve, which is the indifferent curve 2 for the consumer. Alright, so therefore we say that okay, so from the diagram, okay, we can see that the bundle on the budget constraint that cuts okay the horizontal axis okay is optimal because lying on the highest indifferent curve. Okay, because it lie on okay the highest indifferent curve, so it's corresponding to the highest utility level. Okay, so therefore the optimal bundle is still having a utility level of 30. Okay, so the optimal bundle is having B of 15 and C of 0. Okay, and so therefore the utility level of this optimal bundle is just going to be 30. Okay, so if you substitute this value of the optimal bundle into the utility function, we know that is equal to 30, and we know from the diagram that because lying on the indifferent curve 2, which is the line over here, that is why it's having a utility level of 30. Okay. Okay, so now in summary, one very good way of finding the optimal bundle when you have a perfect substitute case is to compare the slope of the indifferent curve and the slope of the budget constraint. Okay, now for the well-behaved preference, to find the optimal bundle, you equate the slope of the budget constraint and the slope of the indifferent curve. Alright. However, it doesn't work in these perfect substitute and perfect complement cases, because these are the two special cases where there's no interior solutions, okay, where we have a corner solutions, and so therefore by equating the two slope is not going to work. Okay. However, one good way of finding the optimal bundle for a perfect substitute case is to compare the slope of the two lines. Okay, so I would just say a note over here. Okay, so you compare the value of the slope of the indifferent curve, okay, and the absolute value of the slope of the budget constraint. Okay, now so if this absolute value of the slope of the indifferent curve, which is basically the marginal rate of substitution. Okay, so I would say this is just basically the absolute value of the marginal rate of substitution, and this is just the absolute value of the negative of the relative price. Okay, so negative say PB negative of the relative price. Okay, so if we have the absolute value of the indifferent curve, okay, is bigger than the absolute value of the relative price, then the optimal consumption bundle is going to be the bundle on the horizontal axis. Okay, so optimal Okay, now if marginal rate of substitution is smaller than the absolute value of the relative price, okay, then the optimal bundle is going to be the bundle on the vertical axis. Okay, and if they are the same, so marginal rate of substitution, the absolute value is the same as the relative price of the budget constraint of the goods, okay, then any bundle on the budget constraint is optimal. Okay, so alright, so these are the very good rules for you to follow to find an optimal bundle in the perfect substitutes case. Okay, now so we're going to go back to our example and see whether it applies. So as you can see, the very first case is where the slope of the indifferent curve is the same as the slope of the budget constraint. Okay, so here is my original budget constraint with a slope of negative 2 on 3, and the slope of the indifferent curves in this case is negative 2 on 3. Okay, so all the indifferent curves having the same slope of negative 2 on 3. So the slope are the same, and so therefore any bundle on a budget constraint is optimal, as you can see on a diagram previously. Okay, now in the second case where the relative price, okay, over here is, so this is my budget constraint. Okay, so the relative price is, so if I got the horizontal, so if I have B on the horizontal and C on the vertical, just like what I have in the diagram, okay, then the relative price has to be B on PC. Remember, like I said before, whatever you put on a horizontal, it has to be going first. So so the relative price in this case is negative, sorry, 10 on 16. Okay, so that is just going to be equal to 5 on 8. I'll just leave it, doesn't matter. Okay. Okay, so that is my relative price, and the slope of the budget constraint, sorry, the slope of the indifferent curve or the marginal rate of substitution is still negative 2 on 3. Okay, so okay, so slope of the indifferent curve or the marginal rate of substitution is still 2 on 3. Okay, so therefore the absolute value of the marginal rate of substitution is equal to 2 on 3. The absolute value of the negative relative price so it's just basically the relative price, okay, which is 10 on 16. Now which one is bigger? So as you can see, 2 on 3 is bigger. Okay, so therefore this thing is bigger than this thing. So marginal rate of substitution is bigger than the relative price. And if that's the case, then we know that the optimal bundle is on a horizontal axis, which is what we already found earlier. Okay, so the optimal bundle is on a horizontal axis where C equal to 0 and B equal to 15. Alright, so you see that it applies here. Alright, so we got this is the case, so therefore the horizontal bundle is optimal, isn't it? Okay, so therefore just have to remember the rules here when you want to find the optimal bundle in the case of perfect substitutes. Alright, and part C asking you what is the change, explain why there is no change in utility, and what do we conclude by the income effect in this case. Okay, so if we're looking back at our diagram over here, before the price change, the utility level for the optimal bundles at 30, and after the price change, the optimal bundle is still on a horizontal axis with the same utility of 30. Okay, So as you can see, that is happening because there is no income effects in this case. The only thing is going on over here is the substitution effect, and that is the reason why the consumer just substitute away to keep the same level of utility. Okay, so that is just the case of perfect substitutions, where the two goods are perfect substitutes for each other. Then whenever the price of one good is increasing, the consumer will just switch totally away from that good and spend all of the money on the other goods. Okay, so as you can see in this case, now before, if the consumer was happy to consume anywhere on a budget constraint, then after the increase in the price of good C, they are switching totally away from good C and only buy only buy good B. So as you can see, the new optimal bundle after the price change is now equal to B equal to 15 and C equal to 0, because the consumer doesn't want to consume any of the C anymore. Okay, so that is called perfect substitute, because they are substituting away from good C because the increase in the price of good C. Okay, so therefore there is no income effect over here, and because there is only substitution effect, that is the reason why the consumer are having the same utility. So they stay on the same level of indifferent curves. They just substitute away from their consumption of good C because the price of good C is now higher. Okay, so I would say there is no income effect.